Triangles. Let's see what we should know about triangles. The first thing to know about triangles, is that every triangle, if you add up the inside angles, A, B, and C, the angles in a triangle must add up to what? 180 degrees, which is quite basically the same thing as a straight line. 180 degrees. So if you know this, so you've got this triangle, and you know this is 15 degrees, and you know that this is 70 degrees, how can you figure out how long that is? Well, you put your 15 with your 70, you know they add up to 85 degrees. The other one has to be what number added to 85? 85 plus how many degrees would give me 180? What would I add to 85 to get 180? Somebody? Abram? 95? Yep. 95 degrees would have to be whatever that angle is there. Have to add up to 95 degrees. Always add up to 180. That's a common triangle thing. Now, forging ahead here, when we talk about classifying triangles, you can either classify your triangles by their angles. This is where people go wrong all the time. Or by their sides. You'll remember this from 6th grade, I'm sure. What are the 3 cases when you have a triangle about their angles? Well, a triangle can have one right angle. Show that by putting that little square in the corner. It can have one obtuse angle. Or, oh wait a minute, yes, no, yes. Yes, no. Right. Or it can have, wait. It can have all equal angles. Those are our 3 choices. What are the exact names of those? Well, if it has a right angle in it, Carter W, it's called a right triangle. If it has an obtuse angle, believe it or not, it's called an obtuse triangle. And if it has all equal angles, it is called oh wait, sorry. They don't have to be all equal. Cancel that, that's where I was going wrong. If all of the angles in it are less than 90 degrees, it is called a Jacob?
Acute triangle.
Yeah, acute triangle. I was getting my things mixed up there, that's why I was. So by its angles, it can either be a right triangle, obtuse triangle, or an acute triangle. Those are your only 3 options. What are your 3 options with sides? Either it can have no equal sides, no equal or it can have two equal sides. By the way, in math, you show they're equal by putting a little slash there. Or it can have all equal sides. And what are those names? No equal sides is, Tyler, a scalene triangle. Two equal sides, Carter A, is isosceles. And all three equal sides, Wade, is a equilateral. Now, something special about the equilateral triangle is that not only are all sides are equal, but in this case, all the angles are equal as well. How many degrees? If you have a triangle that's 180 degrees and every angle has to be equal, what would each angle have to be? Jacob?
60 degrees.
Yeah, in an equilateral triangle, every angle has to be 60 degrees. Doesn't matter how big or how small it is. Even if it's a little runt guy like that, each angle would have to be 60 degrees. So here's an example of this whole messy thing we just talked about here. Let's say you've got this triangle here. And it gives you this. Directions say to classify by both sides and angles. What type of triangle is this based on its sides? Based on its sides. I suppose we should talk about something. Abram, it is?
Isosceles?
It is not an isosceles triangle.
Oh.
Abram?
Equilateral?
It is not an equilateral triangle. Am I looking at the wrong thing? By its sides.
Oh.
If I go back to its sides, where was the one where I did sides? Here, right? It'll have this little thing here that's isosceles. It'll have this if it's equilateral. So it has to be no equal sides, which is, Faith?
Scalene.
Scalene. And then according to its angles, it is, Brant?
A right triangle.
It is a right triangle. How many degrees would that have to be? How many degrees would that have to be? Faith?
30.
30. Why? Because 90 plus 60 plus 30 gives you 180 degrees. Go back to your isosceles one because we probably should talk about this as well. In isosceles triangles, the one thing you need to know about that is the sides that are opposite, the equal sides, also have equal angles. It has two equal angles. This side and this side are equal, so if you look at the angles opposite them, they are also equal. Just for clarification. So there's the sides there. And then the last thing we have to talk about with triangles is the area of a triangle. And what is the formula for the area of a triangle? That one you should know. Tyler?
Base times height.
Nope. That's the area of a rectangle.
Oh.
Area of a triangle is, what's that?
The half of base.
Yep. Area equals 1/2 base times height. And you cannot forget that what are the base and the height and what has to be true about the base and the height? Wade Davis?
Does it have a right angle?
Yeah, these two have to form a right angle? In other words, this, if you are given this triangle, and it says this is 4 inches, this is 6 inches, and this is 7 inches. What two numbers do I multiply together as the base and the height? Amelia?
4 and 6.
So you are telling me that 4 and 6 form a right angle. Do you see a square in that corner of that triangle?
No.
So what two numbers do I multiply together? The correct answer, Wade Davis, is you can't until the book gives you one. They would have to do this. They would drop a line straight down from this, extend this line here, and give you a nice little square corner somewhere on your paper. And then they'd have to tell you how tall that is. Maybe that's 5 inches. Now you can do the problem. Area equals 1/2 of 4 times 5, which would be half of 20, which is in fact 10 inches squared. Now sometimes the right angle is, it's a right triangle and you would automatically have that right angle. If your triangle looks like this and you're given a square corner there, then yes. If this is 8 and 7 and 10, these are your two that form the right angle. They're your base and the height. That's 1/2 of 8 times 7, or half of 56, which happens to be 28 inches squared. But you have to be given two right at a right angle to be able to find out what the base times the height is in that shape. That was certainly the most exciting thing we've ever had here. Perfect, not the first time we had triangles, I don't